Okay, so here with the flower pot, I'm going to show you how to do this problem as the example, and then hopefully you can apply this to the practice problems at the end of the document. So we have a 2-kilogram flower pot dropped from a 10-meter high ledge. How much initial GPE did the flower pot have? So here you just want to use the GPE equation. GPE equals mass times gravity times height. So we have a mass of 2, gravity is always 9.8, and a height of 10. And that gives you, let me calculate it real quick, 2 times 9.8 times 10 gives you 196 joules. And then it says how much kinetic energy will the flower pot have just before it hits the ground. So as the flower pot falls off the ledge, it loses height, but it gains velocity. So that means its GPE from the beginning is transferring into kinetic energy. So all of its 196 joules of energy just before it hits the ground is going to be kinetic. Okay, so all 196 joules energy will be conserved as it falls. It's just changing from GPE to KE. So then we can use that to figure out what velocity it will hit the ground with. So we use our KE equation, 1/2 mv squared. So 196 joules is the amount of KE, equals 1/2 times the mass, which is 2. And we're solving for velocity, v squared. So what you can do is take half of 2, which is 1, and then you would divide 1 on both sides to get v squared alone. So 196 divided by 1 is just 196 equals v squared. And then you take the square root. And the square root of 196, I believe it's 14. Let me check myself. Yep, 14. So v equals 14 meters per second. So just before it hits the ground, it'll be moving at 14 meters per second, assuming all of the energy is conserved.